Hi, everyone. Thanks for joining today. So I'm going to be talking about building a GraphQL service backed by Neo4j. So as Angelica said, my name is Will. I'm an engineer on the developer relations team. What that means is that I don't work on the core bits of Neo4j, the database. Instead, I work on tooling around the database. So things like integrations to make sure that you can use Neo4j with your favorite web development framework, or that you can move data around from different data processing frameworks, things like that. And then I also spend a lot of time working with users to help them be successful building applications with Neo4j. So largely what I'm going to talk about today with this Neo4j GraphQL integration is largely the most recent project that myself and some others on the DevRel team have been working on. So here's a rough agenda of what we're going to talk about in today's webinar. I want to give just sort of a brief overview of GraphQL, if you're not familiar with GraphQL. And then we'll talk about how we can build a GraphQL service on top of Neo4j. We'll take a look at a couple of different Neo4j GraphQL integrations, and then we'll see how this all fits into the GRANDstack. So first, just a very brief overview of GraphQL. So GraphQL is really this new paradigm for building APIs as an alternative to REST. GraphQL starts with a schema definition. And in the schema definition, we define all of the types and the fields that are available on each type. And we also define the entry points for our GraphQL service. These are called query or mutation types in GraphQL syntax. So GraphQL is really a query language for APIs, not really a query language for databases. So GraphQL itself has fairly limited support for what we would think of as queries like aggregations and filtering. Instead, allows us to just select data that's available from an existing schema. Now, there's also many tools that are built on top of GraphQL. Things like Graphical, which is this in-browser IDE for exploring a GraphQL endpoint. We'll take a look at this, this tool in a moment. But because of the strictly defined schema that we use with GraphQL, we can also do things like mock a GraphQL endpoint. So once we've defined our GraphQL schema, we can use introspection of that schema to mock that API so that we can start building out the front end for it before we build out the back end. There are also some great performance monitoring tools for GraphQL as well. Okay, well, let's take a look at an example here. So I'm going to jump into Graphical. So this is this in-browser tool for exploring a GraphQL endpoint. Now, the original problems that GraphQL was created to solve at Facebook were the problem of sending multiple requests to render a view and reducing data sent over the wire. So GraphQL was designed at Facebook initially for their native mobile apps to solve these two problems. So if we look at a GraphQL query here, we can see that we're specifying an entry point, in this case, movies by title. We're passing a parameter that we want to search for, and then we're specifying some fields. This is called a selection set, some fields that we want to bring back. So let's take a look here at the documentation in Graphical. This is going to be our schema. And so we can see here that we have first the query type. This is the entry point for our GraphQL service. And we can see that we have one entry point, which is movies by title. Let me make the font just a bit bigger here. And we can see that movies by title takes a substring and also some optional parameters as well. And it renders a list of movie objects. And if we inspect the movie object, we can see the fields that are available on movie. So things like an ID, a title, year, plot, and so on. Then we can see we also have this field similar, which itself yields a list of movies. So you think of these as recommended movies. So these are movies that are similar to the movie that we're looking at. So let's take a look at an example. Okay, so movies by title with the substring river runs through it, and then we return the movie ID, title, year, and plot. So here's our response. You can see that our GraphQL response matches the shape of our query since we're specifying just the fields that we're interested in for the client. So we can also add additional fields. So let's grab the first 3 movie recommendations, bringing back title and year. So now when we run our query, we'll find river runs through it, and now we have this additional similar field that's giving us movie recommendations. If we like a river runs through it, here are 3 other movies that we might be interested in. Okay, so that's just a simple example of a GraphQL service. Now this is querying a Neo4j database. This is built on top of Neo4j. So let's switch over to Neo4j sandbox. And I spun up the recommendation sandbox and we'll launch Neo4j browser. So let's take a look at what was going on behind the scenes when we were querying Neo4j using GraphQL. Well, if you're not familiar with the recommendations Neo4j sandbox, it's basically information on movies and user reviews of movies. So let's take a look at the data model. So we have movies. We have genre nodes, so movies are in a genre, one or more genre. We have director nodes, directors are connected to movies. We also have actors, and then we have users that have rated movies. So you can see the node labels and relationship types that form our data model. So when we were searching for movies by title, essentially we were running a Cypher query. That's something like this: match a movie where m.title contains river runs through it. And we're just returning that movie node. So here's our movie node, river runs through it, and you can see we're storing as key value pair properties the different fields that we're returning through our GraphQL schema. But we have more data here as well. If we double click on this in Neo4j browser, we can traverse out and we can see, well, here are some of the directors and actors in a river runs through it. We can see the genres, and we can also see these user ratings. So here's a user, Catherine. She rated a river runs through it at a certain timestamp. She gave it a rating of 3.5. So we can also take this information into account to generate our recommendations. So remember, we had that similar field that was showing us movies similar to river runs through it in our GraphQL API. So I have that query saved here. It's a bit more complex. So what is this query doing? Well, it's looking up the movie by title, and then we traverse out to find movies that are in the same genre. And we take account of the number of overlapping genres. And then for this movie, in this case, a river runs through it, we traverse out to find users that have rated this movie to see what other movies that they've rated, what other movies they've watched. And then we take account for the potentially recommended movie. We take account of the number of users that have rated that movie and a river runs through it. And then we take just a simple weighted average here and treat that as a recommendation score. to get Forrest Gump, Titanic, and the Shawshank Redemption, and we have some score associated with those so that we can rank our recommendations. Okay, so that was what was going on behind the scenes when we ran our GraphQL query. Let's see how we can build out a service that does that on top of Neo4j. So in general, building a GraphQL service, there are basically two steps. The first is to define a schema, and then in our GraphQL server, implement what are called resolver functions. And the resolver functions have logic for fetching data from the data layer. So GraphQL is not coupled with any specific database or data layer. In fact, it's designed to be bolted on to any existing data layer. We can query multiple data services. We can even wrap existing REST APIs in GraphQL. So here's sort of an example. On the client, we issue a GraphQL query that goes to our GraphQL server, and inside a resolver function is some logic, in this case for fetching data from Neo4j, to look up a movie, in this case looking up a movie by title, and returning some data about the movie, and then this is sent back to the client from our GraphQL server. So the schema in GraphQL is very important, and this is actually what enables what's called GraphQL first development. So we start with defining the API schema. This then acts as the specification for the API, which means that we can then build out the front end and the back end at the same time. We mentioned earlier that there are these powerful mocking tools that allow us to mock a GraphQL service that allow us to build out the front end while we're still building out the back end. So this is a really, really important tool for being able to improve the productivity of teams using GraphQL. Okay, so we said everything starts with the schema. How do we define a GraphQL schema? Well, we use this schema definition language. This is a language agnostic way of defining a GraphQL schema. In our simple example here, you can see we have a type movie. We're defining the fields that are available on a movie, things like an ID, title, year, plot, and then the similar field that references other movie objects. And then in our query type, which is the entry point for our GraphQL service, we have just a single entry point, movies by title. That takes a substring, so that's the title we're going to be matching against. And then we have first and offset for pagination. And this movies by title gives us an array of movie objects. Okay, so that's our schema. Our next step then is to implement the resolver functions that have the logic for fetching this data from our data layer, in this case, Neo4j. So here's our movies by title resolver function. Each resolver function is passed a few standard arguments. In this case, it's passed the parameters from our GraphQL query, which with movies by title is just this substring, so this string that we need to match against, and then it's passed a context object. Now the context object is useful for passing information like database connections or authentication and authorization headers, things like this. In this case, we have a Neo4j driver instance in the context. So the first thing we're doing is creating a new session for our Neo4j driver. Then we have a simple Cypher query in there to match a movie by title. We use the JavaScript driver for Neo4j, in this case, to execute that query, and then return the results as a list of objects. And this is what our resolver function returns. Although it's important to note that this single resolver function, movies by title, that doesn't resolve all of the fields on a movie's object. Remember, if we remember back to what we saw in Neo4j, we had some key value pair properties, things like year, title, plot that we were storing on the node. But in the case of our similar field of our movie recommendations, we had a much more complex query that we were running there to find similar movies. So the way that resolvers work in GraphQL is the entry point resolver is executed, in this case, movies by title. Then our GraphQL implementation checks to see if there are other fields that were not resolved by this top level resolver. And if those fields were requested by the client, then it will call the resolver function for those fields. So in the case where we specified that we wanted the similar field in our GraphQL query, we would then call the similar resolver, which, as you can see here, is going to execute that more complex movie recommendation query. So let's take a look at an example. This is the Apollo Launchpad tool, which is a great way of just quickly mocking up a GraphQL server. So we have some JavaScript code on the left here, and then on the right, we have that graphical tool embedded for querying the GraphQL server that we just defined on the left. So if we look at this code, we're importing two packages here. One is make executable schema from a package called GraphQL tools. This is an Apollo project that makes it easier to build GraphQL servers starting with just a GraphQL schema. And then we're importing the JavaScript Neo4j driver. So let's look at our code. The first thing we do is define our schema, just our GraphQL schema, just as a string here. So this is the same schema that we saw earlier with a single movie type and a single movies by title entry point for our GraphQL service. And then our resolver functions. So this is exactly the code that we saw earlier. Resolvers is just a JavaScript object that has functions that define how to fetch the data. And in this case, we're grabbing a Neo4j driver instance out of the context. We're looking at the parameters that are passed through to the resolver function and using those as query parameters in our Cypher queries to fetch the relevant data. And we're just returning those as arrays of objects. The only other interesting thing we're doing here is in the context object, we're injecting a Neo4j driver instance and grabbing the Neo4j connection credentials out of environment variables here. Okay, so that's the code for our GraphQL service. So we can run this against Neo4j using graphical. So here we're searching for movies by title. Again, River runs through it and specifying the fields that we're interested in. And this code is online, so you can feel free to play around with this. You can fork that Apollo Launchpad and write your own queries. That's a really cool tool. Okay, so that's sort of the standard approach for building a GraphQL server connecting to any sort of data layer, just writing queries, in this case Cypher. But we wanted to explore if there's a way that we could build a Neo4j GraphQL integration. And what we did is we went out and talked to some users who were using both of these tools to see what sort of things we could build to make this smoother. Could we enhance developer productivity, improve the time to build GraphQL servers on top of Neo4j? To do this, could we translate GraphQL to Cypher somehow so that developers wouldn't have to write those queries in the resolver functions? Is there some way that we could improve performance of our GraphQL implementation? And then we said earlier that GraphQL is somewhat limited in its query functionality. Well, is there some way that we could expose Cypher through GraphQL, sort of enhance the power of GraphQL? So these were the goals that we set out to explore, and we've built 2 GraphQL integrations with Neo4j. The first is a server extension for Neo4j. So this is Java code that's deployed to Neo4j. It then allows you to translate GraphQL to Cypher. Neo4j then becomes sort of the GraphQL server. It serves your GraphQL endpoint. And then the other integration that we've built is a JavaScript version. We call it Neo4j GraphQL JS. And this is designed to work with all of the JavaScript GraphQL implementations. So things like GraphQL JS, Apollo server, and so on. And this also translates GraphQL to Cypher, but it does it in a way that allows you to still query other data services from your GraphQL endpoint, and merely is just sort of a plugin for a JavaScript GraphQL implementation. And we'll take a look at that one in a moment here, but I want to talk just about sort of the process that we use for these integrations. Basically what we do is we use the GraphQL schema to drive what the Neo4j property graph data model should be. And this is pretty easy to do because there's basically almost a one-to-one mapping between a GraphQL schema and a property graph model. So this allows us to translate arbitrary GraphQL queries to Cypher. So here's an example querying for movie by title, river runs through it, and returning title year and IMDb rating. And here's the equivalent Cypher statement that's translated into. So we mentioned that improved performance was one of our goals, and it's interesting to point out that with this integration, we translate any arbitrary GraphQL query to a single Cypher query, which means that there's just then a single round trip to the database. With the standard approaches of building a GraphQL service, there's this n+1 query problem, which what that means is that there are then multiple queries that are generated that need to be batched to be sent to the database. So instead, with our integration, we're generating just a single query, so that's just a single round trip to the database for improved performance. Now, the other thing that we wanted to explore is exposing Cypher in GraphQL. So how do we do this? Well, we use this method in the GraphQL specification for extensibility called a directive. So a directive is a way of annotating a GraphQL field. In this case, we use a Cypher schema directive. So in the GraphQL schema definition, we annotate a field with a Cypher query that then maps that field to the results of that Cypher query. So that field then becomes sort of a computed field. So you can see here in the similar field example, we've annotated that with a simple Cypher query to just, in this case, find movies with overlapping genre, and those become our recommended movies. But we can do this for arbitrarily complex Cypher queries. And those are still translated into a single Cypher query. So in this case, if we add the similar field onto our GraphQL query where we're searching for a river runs through it, we're grabbing some fields including similar movies, well then our Cypher query for finding recommended movies just is executed as a subquery of our single Cypher query that we're generating. So let's take a look now at a different Apollo Launchpad where we're using the Neo4j GraphQL JS integration to query Neo4j. If that loads here, there we go. So the schema that we have is slightly different. Note here that we've annotated, in this case, the similar field with a Cypher query. And we've also added actors. So it's the schema is a bit more complex. The only other package that we're bringing in is Neo4j GraphQL JS, which is that Neo4j GraphQL integration that I mentioned. And then if we look at our resolver implementation, well, this is all there is. So all we're doing in our top-level resolver is calling out to this Neo4j GraphQL integration, passing along the parameters that were passed in the resolver. So passing along the parameters from our GraphQL query, passing along the GraphQL schema, which is here in this resolve info object. And our Neo4j GraphQL integration is able to handle the database call after generating Cypher and returning the data as well. It works by just assuming that there is a Neo4j driver instance in the context object. And so if we look at this now, we can run this this query just to prove that this is working. We're searching for the movie River Runs Through It. We're grabbing, in this case, actors, and then we're grabbing 3 similar movies. Note that we get different results because our similar query here is a bit different than the weighted average query I was using earlier. Okay, so hopefully that demonstrates how simple it is to build GraphQL services on top of Neo4j using our Neo4j GraphQL integration. This Neo4j GraphQL integration is part of what we call the GRANDstack. So that's GraphQL, React, Apollo, and Neo4j database. And these are really technologies that can be used together to build very powerful full stack applications. There are lots of interesting symbiotic integrations that these technologies share that make them very, very powerful choice of stack for building applications. If we see here, this is the diagram that we saw earlier, now slightly modified to show where each piece of the GRANDstack fits in. React, of course, is a JavaScript library for building user interfaces. Apollo fits in as a client integration with React that allows us to bind data in our React components to a GraphQL query. It handles sending that query to our GraphQL service, which we also use some Apollo tooling. We saw the GraphQL tools Apollo package we were using as well. And then in our GraphQL service, we have our Neo4j GraphQL integration, which allows us to generate Cypher queries to send those responses to the client. So looking forward, the integrations that we're building are largely driven by feedback from the community. So if these are tools that you're interested in using, please try them out and let us know what you think of them as GitHub issues, or you can email me directly. We'd really like to know sort of what features are useful for us to build out to support these tools going forward. So I just want to leave you with a few resources. The first one, which we looked at briefly, is Neo4j Sandbox. This is a great way of exploring Neo4j. Neo4j Sandbox allows you to sign in and then spin up Neo4j instances loaded with different data sets for exploring different use cases. The one I was using today was the recommendations sandbox. And then another great resource is the website grandstack.io. This has lots of documentation and tutorials for building out GrandStack applications. There's, and this is linked from grandstack.io, there's a more complete movies workshop that walks through the steps that we did today of first building a GraphQL server on top of Neo4j for generating movie recommendations, but then also goes into how to build out the front end for searching for movies, showing movie details, and then finally showing our recommendations. So that's a good resource to explore if you want to see how the front end piece fits on that GraphQL server that we showed how to build today. And with that, if we have any time left, we'll take a few questions.
Great, thanks so much, Will. We are quite out of time, but I think we can take one or two questions if that's okay. So we have one here that says, if you're working strictly with a JavaScript stack, do you need to use the first Neo4j GraphQL library that you had mentioned?
Yeah, so just to give some clarity on the two different Neo4j GraphQL integrations. So the first one is very tightly coupled with Neo4j. It's code that basically extends the functionality of Neo4j to serve a GraphQL endpoint from the database. And this tightly coupled approach is not always one that you want, depending on what your architecture looks like. So the second integration, that the one that I demonstrated, which we call Neo4j GraphQL JS, is meant to work with any of the JavaScript GraphQL implementations. So if you're using something like GraphQL JS or Apollo tools, any of those JavaScript GraphQL implementations, that's the library that you would want to use that has the functionality for translating GraphQL to Cypher.
Awesome. And is Neo4j GraphQL extension production ready?
So the Java, the server extension is a bit ahead in terms of features of the JavaScript version of our integration. The JavaScript version does not yet support mutations, and there are a few other features that are not implemented as well. So I wouldn't say that it's production ready. It's still an early project, and we're largely looking for feedback from users that are trying it out to help us improve the project going forward.
Okay, great. And we'll just take one more question here. So how would you implement your own business logic, so not Cypher? And could you use Neo4j GraphQL JS with your own resolvers?
Yes, so that's a good question, and that's a good point. That's one of the reasons that we went with the approach in the JavaScript integration that we did, is because we wanted to also allow you to override the default sort of Cypher that's generated with your own resolvers, with your own custom logic. And so if that's the case, if you want to have some business logic, if you want to override the default, you can then just implement your own resolver instead of calling out to the Neo4j GraphQL function for that integration.